بسم الله الرحمن الرحيم. ناظر طلاب الفرقة الرابعة عام شعبة ماثيماتكس. نواصل اليوم محاضرتنا المقرر Applied 12 Special Theory of Relativity. عنوان محاضرة اليوم Relativistic Mechanics Part C. Section 11, the relation between mass and energy. Assuming that the principle of energy conservation is correct in the theory of special relativity, and this principle can be written in the form dE by dt equals F dot V, where E is the kinetic energy of the particle, and from equation 59 we obtain, because F equals d by dt the mv, and F can be written as F equals V dm by dt زائد dm by dt V, and multiplying by V, then F dot V equals mv dot dv by dt plus V square dm by dt. And by differentiating the law of the moving mass m, where m equals beta m naught, then dm by dt can be written as beta square m divided by c square v dot dv by dt. And we can, substituting here, v dot dv by dt from here, then substituting from 63 into 62, then we get F dot V equals C square dm by dt, and F dot V بتساوي dE by dt. dE by dt equals C square dm by dt, then dE equals C square dm, and integrating this relation we get E equals m minus m naught c square. E, the kinetic energy, equals m minus m naught multiplied by c square. This relationship is one of the most important results of the special theory of relativity, and this relation means that the mass difference delta m, which equal to m minus m2, this mass difference delta m is equivalent to an energy E equals delta m c square. This relationship is known as Einstein's law of mass energy equivalent, and the amount m naught c square is called rest energy. Einstein assumed that each mass m is equivalent to an energy E, where E equals mc square. Einstein assumed that each mass m is equivalent to an energy E, where E equals mc square, the square of the velocity of light. E equals mc square. Section 12, longitudinal and transverse mass. Longitudinal and transverse mass. From equation 59 and 64 we get F on the equation of motion. F equals dm by dt v plus m dv by dt, and we get before f dot v equals c squared dm by dt, and we can substitute from this relation from 76 into this relation 75. Then we can get substituting from this relation into this relation, into relation 75. Then we get F equals m dv by dt plus v by c square f dot v. F is the force, the triple force, and dv by dt is the acceleration vector. Now, by analyzing the force vector F, and by analyzing the acceleration dv by dt, and by analyzing the acceleration vector dv by dt into two vector components. One of them is parallel to the direction of the velocity vector, and the other component is perpendicular to it, i.e. F, and by analyzing F and dv by dt into two vector components as F equals F parallel plus F perpendicular. By analyzing the force vector F into two vector components, F parallel plus F perpendicular, parallel to the velocity and perpendicular to the velocity of the particle, and the vector, the acceleration vector dv by dt can be analyzed as dv by dt parallel plus dv by dt perpendicular. and substituting from 78 from these components into 77 to this equation, then we get the following vector components of equation 77 as f parallel equals m dv by dt parallel plus v square by c square f parallel. And we can take this term on the other side, the left hand side. Then f parallel can be written as beta square m dv by dt parallel, and m here is m naught beta. Then f parallel equals this form. This is the first equation of motion. The first equation of motion parallel to the velocity of the particle. And the second equation, which is perpendicular to the velocity of the particle, this second equation of motion perpendicular to the velocity of particle can be written as f perpendicular equals beta m naught dv by dt perpendicular. And from these two equations of motion, we conclude that from these two equations of motion, 79 and 80, from these two equations of motions, we conclude that any moving particle has longitudinal mass, this mass. Then longitudinal mass m naught beta cubic with respect to the influence of the force F parallel to the velocity, to the direction of the velocity v, and this particle has a transverse mass m naught beta, transverse mass m naught beta, in the direction of the perpendicular velocity. This distinction between the two masses of the particle, this distinction between the two masses was observed in experiments of motion of electrons. وشكرا لحسن استماعكم. السلام عليكم ورحمة الله وبركاته.